video, we're going to be learning about measuring segments. So take some time to fill out this warm-up, and then let's talk about segments. So the coordinate is the real number that corresponds to a point. And the distance is the absolute value of the differences of the coordinates. So maybe for A we call that 3, and for B we call that 5. Then the distance AB is the absolute value of A minus B. So notice we don't put a line over it now because we're talking about distance. So the distance AB, we could say, is 3 minus 5, which is the absolute value of -2, which is 2, which is the same thing if we did BA. You could say 5 minus 3, which is absolute value of 2, which is 2. So notice the distance from A to B is the same as the distance from B to A. So that kind of makes sense, but we have the math to back it up now. So our first problem asks, what is ST, which means what's the distance from S to T? So ST is the absolute value of S, so -4 minus 8, which gives us -12. So the absolute value of -12 is 12. And you could always check that by counting 2, 4, 6, etc. and go all the way over. UV is the absolute value. Well, U is 10 and V is 14. So we subtract the 2. So that gives us a -4, which is a 4. Last up, SV is the absolute value of -4 minus 14, which is -18, which gives us a positive distance of 18. So notice, since we take the absolute value, our distance can never be negative. Then we go into something called segment addition. So this sounds a lot more complicated, but it's really just adding up the pieces. So if you notice, I have this little segment AB, and then I have a segment BC, and then I have this big segment AC. So what this says is AB plus BC adds up to give me AC. Or what we say in very mathematical terms, little plus little equals big. So you're going to hear me say this a lot in geometry this year. It's a big theme that comes up a lot. I add a little piece plus another little piece to add up to the entire big piece. So let's try out a few problems. In this first example, I have EG, and they tell me EG is 59, and it wants to know what's EF and FG. Well, EF and FG are labeled. So let's first try to write an equation. So I know this little segment EF plus this other segment FG equals EG. The biggest mistake people make is not writing this equation first and then mixing up some of the numbers. So now we'll plug in what we know. EF is 8x minus 14. FG is 4x plus 1. And it adds up to this total number 59. Now I'm just going to combine like terms, solve for x. So 8x plus 4x is 12x. -14 plus 1 is -13 equals 59. I'll add 13 to both sides. And I'll divide both sides by 12. So I get x is 6. But the question asked, what's EF and FG? So I'm going to take 6 and plug it back in. So EF is 8 times 6 minus 14, which is 34. And FG is 4 times 6 plus 1, which gives us 25. So now I know 34 plus 25 is 59. I can check it by making sure that they add up. So yes, 34 plus 25 gives me 59. This next problem says JL is 120. What are JK and KL? So JL is 120. I'm going to first write my little plus little equals big equation. So JK plus KL equals 120, which means 4x plus 6 plus 7x plus 15 equals 120. I'll combine like terms, so 11x plus 21 equals 120. 11x, if I subtract 21, is 99, which is x equals 9. And now I'm just going to plug back in. So for JK, that's 4 times 9 plus 6, which is 42. And KL is 7 times 9 plus 15, which is 78. And I can always check my answer by making sure 42 plus 78 is that 120, and yes it is, so I know I did it right. Next up, we're going to talk about something called congruent. So something is congruent. We use this little symbol, and it means when two segments have the same length. So let's try it out. Are AC and BD congruent? So let's see what AC is. AC is -2, and look, these go up by 2, so C is at 5. -2 minus 5, which is a -7, which gives me 7. BD is 3 minus 10, which is a -7, which gives me 7. So yes, AC is congruent to BD. Let's try the next one. Is AB congruent to DE? So AB is -2 minus 3, which is -5, which is 5. DE is 14 minus 10, which is 4. So no, those aren't the same number. So AB, we'll put a line through it, is not congruent to DE. Next up, we come up with something that's called a midpoint. So you've probably heard of this before. It's the point that divides a segment into two equal parts. So if I have A and B, my midpoint M is right in between, and it divides this into two equal parts. I use these little tick marks to show that side's the same as this side. Kind of related is something called a segment bisector. So this is something that splits a segment into two equal parts. You might be saying, how is that any different from this midpoint? The only way it's different is I've got my A and B, and now it's this line is my segment bisector S. But notice it goes through the midpoint, so they're really related to each other. So in this example, it says Q is the midpoint of PR. Right away when I hear that, I'm going to draw little tick marks the same on each side to show these two things are equal. And it says, what are PQ, QR, and PR? This brings me to my next very mathematical statement that we're going to see a lot in math class. So if they're equal, set them equal. So P, Q, and QR are equal. Why not just set them equal then? 6x minus 7 equals 5x plus 1. Solve for x by subtracting 5 on both sides. So 5x on both sides, so x minus 7 equals 1. So x equals 8. Now let's plug in. PQ is 6 times 8 minus 7, which is 41. I could plug in to 5x plus 1, but if they're the same, why do extra work? I can just say QR is also 41. That means the entire thing is double of that, so PR is 82. You could always check by saying, plugging in everything, making sure everything's equal. Same problem on the next one. It says U is the midpoint of TV. At this point, I'm going to draw little tick marks to show these are equal. If they're equal, set them equal. So TU is equal to UV. So 8x plus 11 is equal to 12x minus 1. So 4x is equal to 12. So x is 3. Which means TU is 8 times 3 plus 11, which gives me 35, which is the same as UV. And if they're both 35, they have to add up to TV, which would be 35 plus 35, which would be 70. Lastly, we're going to figure out how to find the midpoint. So to find the midpoint of something, we're going to take the average. On a number line, all we're going to do is average the coordinates. So what does that look like? That looks like us saying, well, a plus b divided by 2. So that's negative 4 plus 9 divided by 2. Will give us the averages is 5 divided by 2, which is 2.5. We can check to make sure that makes sense. Look, so if there's 2.5 is right here, that makes sense. That looks like it's in the midpoint. For the coordinate plane, we're going to average the x values and average the y values. And that's going to give us our new point. So the average x value and the average y value. So for x, our average is 7 plus 2 divided by 2, which is 4.5. And for y, our average is 5 plus negative 4 divided by 2, which is 0.5. And we're just going to turn that into our midpoint. So the midpoint is 4.5, comma 0.5. The last thing we might encounter is we have a midpoint and we have one point and we want to find the other endpoint. So the midpoint of CD is right here and it's negative 2, 1. One endpoint is negative 5, 7. So we can figure our midpoint D, is going to be somewhere over on this side on this line. But we want to find the exact point. What you're going to do is stack your points. So what I mean by that is write them in order. So we're going to write C, and then it goes through M, and then the line goes to D. C is negative 5, 7, and M is negative 2, 1, and I want to know what D is. The way I'm going to figure it out is I'm going to figure out how did I get from here to here. To get from negative 5 to negative 2, I add 3. So then to get from the midpoint to the next point, I'm also going to add 3. Negative 2 plus 3 gives me 1. Same thing for the y values. How did I get from this y value to this value? I subtracted 6. So to get from this one to this one, I'm going to subtract 6 again to get negative 5. So here's our point D. Which makes sense. It's actually right down there. We guessed pretty close to where it was. Now we have the midpoint of AB is M. So let's try to draw this out just so we're sure. We've got this AB, and we've got our midpoint M, wherever it happens to be. So let's write A, M, B. A is -3, -5, and our midpoint is 4, -9. And I want to know what B is. Let's figure out how we get there. How do I get from -3 to 4? I'm going to add 7. So to get from the midpoint to B, I'm also going to add 7. 4 plus 7 is 11. To get from -5 to -9, I subtract 4. So to get from -9 to the next thing, I'll subtract 4. So I get to -13. And there is my point B.